Today we're going to be talking about choosing the best method to solve quadratics. The four methods that we've talked about are solving by square roots, by completing the square, by factoring, and by quadratic formula. So first we need to remember, when can we actually solve by these methods? And I would say these are the order that I would look for them in as well, from easiest to, I'm going to say, hardest, or most specific place you can use them to the most general place you can use them. So for square roots, that's when there's no x term or no linear term. That's the only time you can use square roots. Completing the square, we want to make sure that we have a 1x squared, okay? So just an x squared and an even b value. So again, remember that all quadratics are ax squared plus bx plus c, so that number on the linear term with the x needs to be even in order for us to complete the square. Factoring, well, of course, it must be factorable to use factoring. And the last method, quadratic formula, this can be used with any problem. So as long as it is a quadratic, meaning the highest exponent is 2, the quadratic formula works. Okay, so that's why that's the most specific to the most general. Now, if we look at 4 different questions here, and we need to decide which method would be best to solve each quadratic equation. So all of these are quadratics because they all have an x squared there. Okay, so again, the first method that I said I would look for is square roots. That's the easiest to look for. That would be where there's no linear term. So which of these questions does not have an x term? That would be number 2 here. So that's going to be the one we're going to solve by square roots. The next one to look for is completing the square. So we want to make sure that we have just an x squared. So number 3 we can't use because there's a number in front of it. If we hadn't chosen this one as square roots, we couldn't do that either because that has a 7. So it's either 1 or 4, okay? We need a 1x squared and we need an even b value. So here the b value is 6, that's even. Here the b value is -3, that is not even. So here this is even. Now, it could be the case that this one could be even as well. You just got to be careful here with these things, but this is one that we're going to use complete the square for. Which means this one here is going to be factoring. Now, keep in mind, this one up here as well that we chose for completing the square actually is factorable. You may or may not notice that, but you can use completing the square, you could also use factoring. Okay, so there's, just because I said completing the square here doesn't mean you have to use it. You could use other methods, okay? But I'm going to say that's the best method to choose for that question. And then here this leaves number 3 as our quadratic formula question. Okay, so we're going to go through and actually solve each of those questions using the method that we have chosen, just to refresh your memory with all of the methods, since it's been a bit of time since we've seen some of these methods and kind of just a whirlwind of information. So we have, for square roots, 7x squared equals 49. Again, we know that we have to use square roots here, or that would be the best method because there is no x term. Now, with solving by square roots, we are going to make sure that we get the x squared by itself. So this does not have to be equal to 0. So that means we're going to divide by 7 on both sides, and we get x squared equals 7. The inverse operation of that square is to take the square root on both sides. So when we do that, we know we're going to put plus or minus. 7 is not a perfect square, but you can take the square root of it and round it to 2.65, or 2 65 hundredths. Okay, so remember, you do need 2 answers. Square roots is easy, but you have to remember the plus or minus. All right, next method is completing the square. So that's the question that we chose here, x squared plus 6x minus 7 equals 0. So for completing the square, we do need to make sure that we're moving the constant over to the other side and that we are putting in our blanks. So this constant of -7, we would add 7 to both sides and get 7 plus blank over there. To find that magic number, we do need to take our b value. So let me move this over a bit. Our b value is 6. We divide it by 2 and we square it. So half of 6 is 3, and 3 squared is 9. So here our magic number is 9. Now that we have this, we're going to factor the left-hand side. So it's going to be x plus 3 squared, and 7 plus 9 is 16. Now we're solving by square roots, which is very similar to how we did it in that first example. To get rid of that squared, we are going to take the square root on both sides. The square root and the square go away, so we're left with x plus 3 equals plus or minus 4. We have two cases to be in: x plus 3 equals positive 4 or x plus 3 equals negative 4. And then we're solving those two. So we would subtract 3 on both sides here to get x equals 1. We would subtract 3 over here to get x equals negative 7. So those would be our two answers. Now remember, with each of these things, we can always plug the number back in to the original question. You can also work on graphing them to double check what they look like. Okay? Next question, we're going to solve by factoring here. We have x squared minus 3x minus 4 equals 0. So you would need to recognize that this is factorable in order to solve it by factoring. So it's equal to 0. The first two spaces need to multiply to give us x and x. The back two spaces need to multiply to give us a negative 4 and add together to give us a negative 3. So that means that we need one of each sign. We're going to need a positive 1 and a negative 4 to make this happen. And once we have it factored, we're going to set each term or each factor equal to 0, and then we solve it. So here we would subtract 1 from both sides and get x equals negative 1. Here we would add 4 to both sides and get x equals 4. Okay. The last method that we are dealing with is quadratic formula. So we have 2x squared minus 7x equals 12. In order to solve this, we do need to make sure that it's in the proper form, so it needs to be equal to 0. That means we need to subtract that 12. Okay, so 2x squared minus 7x minus 12 equals 0. Remember, this is our A, that's our B, here's our C, so we're going to fill into that formula. X equals the opposite of B plus or minus the square root of B squared minus 4 times A times C all over 2 times A. All right, that's going to give us x equals 7 plus or minus the square root. When you do the math of all of this here, you will get 145. And then it's over 4. So we have our two different situations that we are in. Either x equals 7 plus the square root of 145 over 4, or x equals 7 minus the square root of 145 all over 4. And those we're going to type into Desmos to get the answers of. Remember, when you do this, there's those implied parentheses that we need to type in order to make sure that we're getting it correct. So we have 7 plus the square root of 145. Let's see here. Divided by 4. So we're going to round to the nearest hundredth for this. That means that we're going to get 4.76 or 4 and 76 hundredths. We're going to go in and change that addition to a subtraction sign. And for our other case, we're going to get negative 1.26 or negative 1 and 26 hundredths. Now, remember, in the grand scheme of things, for all of these questions, we'll use this one. It's got to be equal to 0 for you to do this, but I could type in the 2x squared minus 7x minus 12. You do not need to push the equal 0 at all. And if you look here on the graph, it's going to tell us that we cross at 4.76 and negative 1.26, which are the two answers that we got when we did it by hand. Okay, so you can always check them that way as well. And that's it.